Hello everyone, we are Group 1 and our topic is gas-fired power generation. So we are going to start our presentation now. So our team members, there's 6 people. First is Loke, Seng, there's Heng, Wong, Xian, SARVEEN anak laki GUNALAN, Gokula, Vikneswaran anak laki Paramasibam, and lastly DHANAKUMARAN anak laki KALAI.
Today our group will be presenting on gas-fired power generation. Gas-fired power generation is the process of producing electricity by combusting natural gas to drive turbines connected to generators. Natural gas is mainly composed of methane and one of the most widely used fuels for electricity generation around the world. As one of the cleanest fossil fuel options, gas-fired power generation offers several advantages, including high thermal efficiency, operational reliability, and lower carbon emission compared to conventional coal-fired power plants. Due to this benefit, it has become an important technology in modern electricity generation. Support our gas-fired power plants plays a critical role in the modern energy sector by providing a reliable supply of electricity to support homes, industries, business, and cities. They help meet the growing global demand for electricity while maintaining efficient and dependable power generation. Their widespread use around the world demonstrate their importance in supporting economic growth and modern development. Because of their reliability, efficiency, and comparatively lower environmental effect, gas-fired power generation continues to be an important part of today's energy mix. With this introduction, let us now move on to understand the operation and basic principle of a gas-fired power plant.
Hello everyone, today I will explain the basic construction and working principle of a gas-fired power generation system. The system converts the chemical energy of natural gas into electrical energy through several important stages. Firstly, air intake. First, air is drawn into the system through the air intake. Filters remove dust and moisture to ensure clean air enters the power plant. Next, compressor. The clean air enters the compressor. The compressor increases the air pressure, which improves the efficiency of the combustion process. Next, combustion chamber. After that, the compressed air is mixed with natural gas in the combustion chamber. This mixture is ignited, producing high temperature and high pressure gases. Next, gas turbine. These hot gases then flow through the gas turbine. The force of the gases causes the turbine blades to rotate, converting thermal energy into mechanical energy. Then, generator. The rotating turbine shaft is connected to a generator. The generator converts the mechanical energy into electrical energy. Then, electricity delivery. Finally, the generated electricity is transmitted through transformers and power lines to homes, industries, and businesses. In conclusion, a gas-fired power plant generates electricity by drawing in air, compressing it, burning natural gases, spinning a turbine, and driving a generator. This process provides a reliable and efficient source of electric power. Thank you very much. The process begins with the compressor sucking in vast quantities of air and squeezing it tightly. This compressed air then flows into combustion chamber where it meets the fuel. The mixture is ignited, creating an intense inferno of hot, expanding gases. Imagine a controlled explosion that releases tremendous energy. These gases then rush through the turbine, pushing against its blades with incredible force. This spinning force or rotational energy is what drives the generator connected to the turbine. As the generator spins, it creates the flow of electrons that we call electricity. This electricity is then distributed through power lines to our homes, schools, and businesses.
Now I like to explain about how does a gas turbine work. A gas turbine converts energy of burning gas into mechanical rotating energy. Firstly, air intake. Air is drawn in from the outside into compressor. The next stage is compression. The compressor pressures the air into a high pressure. After that, in the combustion chamber, the fuel is injected and burned. The hot gas expands and flows through the turbine. Then, the gas turns the turbine blade producing power. Finally, the exhaust gas are released into the atmosphere. Next, I like to show a short clip about gas turbine. So how does a gas turbine work? First, air enters through the turbine inlet. Next, the compressor increases the air pressure before it enters the combustion chamber. This compressed air is then mixed with fuel and ignited, creating an expanding hot gas. Finally, this hot gas drives the power turbine and generates mechanical energy.
I'm going to explain about the basic principles of gas-fired electrical generation. So to understand how gas power plants maximize energy output, engineers rely on a few foundational principles of physics and thermodynamics. So for the thermodynamic cycles involved would be the Brayton cycle. This is the ideal thermodynamic cycle for gas turbines. It involves isentropic compression, which is squeezing the air without heat loss, isobaric combustion, burning fuel at a constant pressure, and isentropic expansion, extracting the work through the turbine blade. The second thermodynamic cycle involved would be the Rankine cycle. It is used in the second half of a combined cycle gas turbine plant. It focuses on changing the phase of water from liquid to high pressure steam, expanding it through a turbine and condensing it back to water to repeat the loop. So the entire operation is a chain of energy transformation, which starts from the chemical energy, which is gas, and into thermal energy, which becomes fire, and then it transforms into kinetic energy from the spinning blade, and lastly it transforms into electrical energy, which can be used.
Now I want to talk about the efficiency and exergy destruction. First, for the thermal efficiency, a standard simple cycle turbine converts roughly 35% to 40% of the flue chemical energy into electricity. Combined cycle plants push this boundary, achieving efficiency outward of 60%. For the second, exergy destruction. In thermodynamic terms, a huge amount of potential work exergy is destroyed during the combustion pressure because of the massive temperature difference between the flame and the air mixture. Keeping the turbine inlet temperature as high as metallurgically possible is the key to minimizing this loss and keep efficiency high.
Good day everyone, my name is Wong Xian. Now I will talk about the example of gas-fired power generations. First of all, we have Track 4A Combined Cycle Power Project, which located in Pasir Gudang, Johor, Malaysia. It is contribute a total capacity of 1,440 megawatts of power, and it is split into two identical 720 megawatt blocks operating on a single shaft configurations. Each block of it features an advanced General Electric 9HA.02 heavy-duty gas turbine acting as a primary mover. To maximize the efficiency, a horizontal heat recover steam generator captures the exhaust heat, channeling it into a GE steam turbine to produce a secondary power without burning extra fuel. Furthermore, Track 4 ensures strict grid security through its dual fuel flexibility, relying on natural gas as its primary source and distillate oil fully integrated as a reliable backup. For the second example, we have the Futsu station located at Futsushima, Japan. This is one of the largest and most advanced thermal power facilities in the world, boasting a staggering total capacity of 5,040 megawatts. Futsu station achieved this massive output by utilizing four distinct groups of advanced combined cycle units. It leveraged cutting-edge turbine technologies, deploying both GE frame 9HA turbines and Mitsubishi advanced MACC systems. From an environmental and logistics standpoint, the station is seamlessly integrated into Japan energy infrastructure, where it is fueled clearly by liquid fuel natural gas, which is also called LNG, delivered directly through an undersea pipeline from the neighboring Futsu LNG terminal. Together with these two facilities, it perfectly demonstrates why gas-fired generation remain indispensable, whether it is the modular flexibility and heat recovery efficiency, like in Malaysia Track 4A project, or the massive pipeline integrate base load capacity of Japan Futsu Station. Modern gas power plants provide the reliably, highly efficiency power required to keep our world moving forwards. Next, we will take a look on our reference for these presentations, and this will be our reference, and this will be the end of this presentation. Thank you.